how we actually graph absolute value. And today we're going to take that one step further and learn how to graph absolute value inequalities. So it's very similar to what we've done before. You're still going to graph the y equals absolute value function, and then use a dotted line if it's less than or greater than, and a solid line if it's greater than or equal to, or less than or equal to, and then test a point to try to decide where the shading should go. So there are other ways that you can quickly graph absolute values, and we'll talk about that in the near future. But for now, we're going to go ahead and just simply use XY tables to help us graph them. So you'll need to graph enough points until you are comfortable that you have the V shape that you need. And until you start to see that V shape, you'll need to graph more points. Some absolute values will fall, the V shape will fall right on the x-axis. Some will be in one of the four quadrants. So this is a pretty easy one. You're really essentially graphing y equals x, but it will meet at 0, 0. So if we plot the point x equals 0, we fill in 0 for x, then y would be 0. There's 1 point. If x equals 1, the absolute value of 1 is 1. If x equals 2, the absolute value of 2 is 2. And you could see how for negative 1 and negative 2, you get the absolute values of those, and you get 1 and 2. And so now we can go ahead and graph those, because we're fairly comfortable that our graph will look like this. Now it's a matter of testing a point. And when we test our point, I'm going to use the point 0, 2. So when I test the point 0, 2, this guy right here, I'm going to fill in 2 for y. And is that less than or equal to 0? Is 2 less than 0? No. So that means the shading wouldn't be here, but instead the shading would be down in this region. And so everything below the graph will get shaded. And that makes sense because we want all the y values to be less than the absolute value function. Okay, you're going to try two of them right now. You're going to try this one first. So go ahead and pause the video and try to construct that absolute value graph in the next couple of minutes, and then start the video to check your answer. So our solution for this, we make our XY table, and we start to fill the table out. When we put 0 in for x, we're going to have 2 times 0 is 0. The absolute value of 0 is 0, plus 1 is 1. So there's the point 0, 1. If we plug in 1, 2 times 1 is 2. The absolute value of that is 2, plus 1 is 3. And if we plug in 2, 2 times 2 is 4. Absolute value of that's 4, plus 1 is 5. Let's try some negatives. So the negative 1, that's going to give me negative 2. The absolute value of that is 2, plus 1 is 3. And the same thing happens for negative 2. So it looks like I have my V shape happening here. It looks like I bottomed out. So now we can go ahead and graph that. And we'll graph it on this side as well. So now when we go to test a point, I'm going to test the point 0, 0. So is 0 greater than or equal to 0 plus 1? And that's false at this point. So therefore that means my shading will be above the absolute value graph. So it will be right inside this region. For your last problem, attempt to graph this. Pause the video and graph it, and check back in to see your answer. Okay, for this one, again, we're going to make our table. So when I plug 0 in, I get 0 minus 3. Absolute value, that's 3. 3 plus 1 is 4. So 0, 4. If I try 1, 1 minus 3 is negative 2. So that would be 2 for the absolute value, plus 1 is 3. Looks like we're going downward here. Here's 2. 2 minus 3 is negative 1. That's 1 when you take the absolute value plus 1 is 2. For 3, 3 minus 3 is 0. 0 plus 1 is 1. How about for 4? 4 minus 3 is 1. 1 plus 1 is 2. Looks like we've finally bottomed out. And for 5, you'll notice we get 3. So it looks like we've got our absolute value built. So let's go ahead and graph that guy. And when we test our point, we're going to test 0, 0. So we want to know, is 0 less than or equal to 0 minus 3, absolute value is 3 plus 1, which is 4. That is true. And so the point 0, 0 was in a true area, so that means we can shade everything down here. Okay, now you're ready to start solving some of the problems posted around the room.